When we started in 2013, there was a void in the 3D printing market. On one side, small desktop 3D printers were available, but limited your capacity to print huge. On the other side, large industrial 3D printers with a $100,000 cost barrier to entry. They also took a lot of power and used expensive proprietary materials that were not accessible to a global community. As a spin-off of Engineers Without Borders, NASA Johnson Space Center, we built Gigabot, the world's first affordable, large format industrial 3D printer starting at under $15,000. It is hand-built with precision manufacturing in Austin, Texas, using primarily materials found in the United States. Every improvement is offered as a path to upgrade, so it never becomes a paperweight, and its open source design allows anyone to maintain it. Gigabot enables change makers in over 50 countries to 3D print at the human scale. We began with just $40,000 in capital from Startup Chile, and with the help of supporters from Kickstarter backers to the National Science Foundation, we've grown to support a global community. Our team of space geeks has over 100 years of manufacturing expertise to take on the hardest challenges in material extrusion. Our social mission is the core of who we are. We operate under a 1 for 100 model, where we give away 1 gigabot for every 100 we deliver. From the beginning, our founders wanted to tackle 3 solutions for communities. 1, provide access to manufacturing. 2, provide a tool for economic mobility. And 3, find a way to reuse the trash in their environment. This is a view of plastic waste found around our outpost in Puerto Rico. Landfills there are overflowing. It's estimated that in 2 to 4 years, they will be out of space. These images are also representative of trash found in Texas. Annually, we toss out $80 to $120 billion worth of plastic per year, less than 10% of which is recycled. But where some see trash, we see opportunity. That's right, garbage. By leveraging the waste in our communities, you can bypass pricey raw materials like filament and instead use granulated waste plastic as feedstock to create new products, which in turn, at the end of their life, can be ground up and used again to enable a circular economy. An unfortunate truth about the world is that everyone has access to plastic waste. This is Gigabot X. Instead of filament, it 3D prints directly from pellets, flake, or granulated plastic trash. It builds on our proven Gigabot platform to enable your products to be made sustainably. It prints up to 17 times faster than our filament-based printers. With NSF SBIR funding, Gigabot X was conceived and commercialized, along with the GigaLab, a containerized solution that truly democratizes 3D printing technology, allowing anyone, anywhere, anytime to dream big and print huge, while having complete control over their supply chain. We are meeting the UN's Sustainable Development Goals in industry, innovation, and infrastructure, and responsible consumption and production. We can help the cities of Houston and Austin meet resilient city and climate goals for transforming the way people think about recycling. We are seeking strategic partnerships with municipalities and industry to integrate Gigabot X into reimagined waste services and factory operations. And we're not just talking about it, we're doing it. Our engineers granulate plastic, study it, and use it again to print real functional objects. They make test prints and then progress to more complex geometries and products. This chair was made in partnership with Habitat for Humanity Restore. It is 3D printed using recycled PET water bottles and reclaimed scrap wood from construction sites. We also work with the plastics manufacturers to test and validate their materials to be used in our large format 3D printers. Re3d is honored to now be scaling this concept in space via NASA Ignite, as well as on Earth through a $4 million NSF Convergence Phase 2 contract. In parallel, re3d was contracted via an Army X-Tech Sequential Phase 2 award to make a greater than 1 meter by 1 meter high throughput pellet printer that can accept natural fibers plus waste in a containerized format to make pallets and other large objects point of need. Where we go from here is dependent on your feedback. We look forward to talking to you further. We would also love to invite you to take a tour of our Austin factory near the airport and visit the Giga Lab located at the Austin Habitat for Humanity Restore on Ben White, as we work with the community to enable affordable, sustainable, locally driven manufacturing. Thank you very much.
Woo!
Yes.
Can we try printing something and then grinding it up and then printing it again?
We didn't bring the grinder. We brought the printer, and it has been printing it's all day today. And so there are things over there. There's several items that have been printed today, as well as items that have been printed at the Habitat for Humanity Restore. The coral you see here is taken from a 3D scan of actual coral off the coast of Puerto Rico, and it's being used to help rebuild the coral that was devastated in one of the recent hurricanes.
Where is the 3D printed stuff?
Directly behind. If he goes just straight that way, it's right over there, all set up. This is an example. So this is one of those kind of plastic water bottles that you can actually grind up and use to print from. And the stuff you see in it is the water bottles that have been ground up to print.
Wait, could you use like a coffee grinder?
Yes.
No.
Yes.
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 Oh, yes. That's Taylor. She works with me.
Wait, could I attempt to print something?
Ask him here so everyone can hear, please.
Could I attempt to print something
Okay, you got it.
specific? Specifically, like miniature version of one of the Japanese gate things, because a couple years back at my school, we had a 3D printer, and we were trying to get it to work, and that was our test print. It never worked, though.
Oh, okay. Do you have the model with you?
No, but I downloaded it for free.
Okay.
I just looked up free 3D printing models.
Oh, okay. Yeah. Any 3D model can be printed on our printers. So if you had anything available, it would be able to be printed on there. We brought, was it 3 different models? A smaller vase?
A smaller vase, a larger vase, and a
larger
coral.
vase, and the coral.
Can you buy the big 3D printer? Can you buy them?
Yes, they are for sale. We have the one that's over there is our smallest version, and they get bigger from there. This one, is it 15?
20?
20.
20,000?
The one we brought is 20?
Yes,
okay,
20,000.
So the one we brought is the $20,000 model. We have, goes up to Exabot, I think is the biggest, but we don't sell many of those. They're huge. The Terabot, how much is that one? Do you know?
I think it's around 115.
About 150,000? Okay.
How big is the biggest one?
That's the Exabot. That's the one, it prints up to 7 feet tall, I believe.
Yes.
It's
Wow.
bigger than my arm span. It's huge. When you build it, you stand inside of it to assemble it.
Yeah.
Yeah.
Have you ever heard of? It's some project someone made that bows a 3D printer that can make itself bigger. It can 3D print
Pieces to make itself bigger.
pieces to make itself bigger onto itself.
I've heard of similar projects. I don't know if it's the same one that you're talking about, but there's the RepRap project, which it's for building printers that can then print
Like that.
more of themselves.
Yep.
Yeah.
It was something like that.
Yeah, RepRap. I think it's reprap.com or .org, something like that.
Also, is there any specific file format?
It can do STL, G-code,
Step and
Step.
3MF.
and 3MF.
Can I use .blend files?
I don't
No.
know, I'm not familiar with that. Taylor says no.
No.
She does our customer support, so she would know.
You can design it in Blender, and then whenever you export it as an STL, you put in the slicer, and then you export it as a G-code, and then you can print it.
Yeah, so if you can get it into a slicer, there's a lot of free open source slicers like Orca Slicer. That's one that we use internally, and it's a really good one. But yeah, if you can import it into your favorite slicing app, then you can export it as a compatible format for our printer.
Is there any way you can get some of the technology on a home printer scale? Like the being able to take little ground up bits of plastic. Could you take that system and miniaturize it to like a commercial 3D printer for home?
Maybe. We do make our designs open source, so it's possible someone could take them and do it. I don't know of anyone who has, but it's possible.
The closest thing we've done is that NASA one.
Oh, the NASA one. Yeah, we built a printer for NASA. It's smaller than this one. It's a one-off unit just for NASA.
What's the biggest,
Take up into space.
What's the biggest thing you've printed?
That I've seen, maybe Taylor knows better, but that I've seen are rockets. Those are the 6 or 7 feet tall rockets. They're about this big around.
That's like tall. That's taller than me.
Yeah,
Yeah.
Yeah,
taller than me.
it's very tall.
That's really tall.
Wait, if I theoretically shrunk it down a little bit, just a little bit, so it still worked, could I 3D print it in that one?
3D print what?
The frame for a smaller 3D printer?
Oh, 3D print a printer frame inside. Yeah, just the frame. Maybe, although it wouldn't be strong enough to actually be used as a 3D printer. It could be used as like a display model. Yeah.
Some of the parts of the 3D printer over there are 3D printers.
But not by that thing. And like not the whole thing.
Not the whole thing, no. The only parts.
If I were to make a model of a smaller home version, could I give that model to you and then you could sell it?
We do contract printing, so yeah, we can do it.
Yeah.
I mean, it would make you more money because
Yeah.
3D printers are very popular among kids wanting to make 3D printed toys.
And the smaller,
That is
I
true.
know from my sister.
Oh yeah.
the smaller one would cost less, too.
It
Yeah.
costs less to manufacture, and if it had the same technology, it would probably be one of the best
3D printers.
3D printers on the market.
Well,
Yeah.
see, that's an open.
Because then you wouldn't need to buy a film.
Is,
You could just
if
chuck your drive
it's
in
open
trash.
source, could somebody download the plans, maybe add some modifications, and then actually market them themselves, like people do with the Raspberry Pi?
And if you made
Yes.
smaller ones to
We have
market-
customers that do
Yeah,
that.
it is possible.
Yeah.
And if you made smaller ones to market, then the person who had it wouldn't have to buy film and they could grind up plastic.
Right. Yeah. Get a grinder. Take your own plastic waste.
Yeah,
Like-
instead of having a recycling bin, they could have a bin that goes into the 3D printer.
So the Habitat for Humanity Restore, they get thousands of those plastic tubs. People bringing stuff in to donate the stuff that's in the bin, and those bins are then ground up and used to print things that they sell in a store.
you could just sell a smaller, like miniature grinder, maybe the size of a plastic water bottle, and then a grinder, maybe a container for storage, and
Bowl for the kitchen.
a smaller version of the 3D printer, and then you could print bowls for the kitchen.
And that means you wouldn't
Yeah.
have to buy silverware and
Bowls.
you wouldn't have to buy bowls and plates anymore.
Very Solarpunk.
Is it food safe though?
Very much.
It depends on the kind of plastic.
You
Yeah,
could
so-
you could make it food safe. Depends on what you put into it.
Fair enough.
Yeah. So if you print with PLA, which is like a common filament used on home desktop 3D printers, that's not food safe. But things like
But it would
PETG,
but the 3D printing, the plastic you would use would probably be a little more safe than the regular 3D printing silicone plastic.
yeah, it could be like the
Yeah.
this I believe is PET, so it's not PLA, so it could be food safe.
You could grind
Look
down.
first though.
You could grind down all the food safe plastic forks that you get when
Oh yeah.
you get food from a food truck,
Oh,
and then
I was thinking about that. Yep.
I didn't think of
And then one fork is just one fork.
Sorry, what was that?
One fork is one fork.
Yeah.
fork.
Yeah.
Spoon is one spoon.
Okay. Well, I think I am out of time, so
All right.
I will call it a day.
Well, hope you think about a smaller commercial version of it.
All right. Cool.
It would be probably one of the most popular if it worked well.
Sounds awesome.
You want to come intern for us?
Yes.
Yeah.
I'm trying to get a job.
When you're older, yeah.
Where
Come.
are you
Do
based
it
out of?
next year.
We're in Austin, Texas, across the street from the airport.
Okay. Okay.
re3d.org.
Yes.
Yes.
re3d.org.
All right.
We'll see you then.
All right. Thank you.
Woo!